Hey everybody, I'm back with another update to my progress learning the shader lessons that I found on YouTube. I saw two videos this week about Raymarching, and this time we learned about shading and light reflections. So you can actually make it look like it has a surface on it, like there's light beaming down. So anyway, we added two new inputs here, and then we also added some new things to the HLSL code. I'm going to put a picture up real quick of what it looked like once I learned the first lesson, just to compare it, and then we'll have a look at where we are now. So, I'll explain what we've added so far. So, you'll notice here that we've added a 1 minus and a negative 1 to our ray origin and ray steps. That's so that all of this looks right, basically, because for some reason, if you have some of these set normally, it actually, let me just do it over here. It makes it look like the shadow is in the wrong place. So you kind of have to flip it. Yeah. So that's that change. And then we added a few things. So first we added the float 3 light direction. It's just a normalized vector of the light position, which is this 3 vector. And then in the if dist statement, we added a few things. So first off, we added this float 3 called normal. It's a normalize of ray origin minus sphere center. And then we added diffuse, a single float, which is a max value of a dot value, which includes normal, comma, light direction, and 0. So we take this, put it here, then if we multiply our original float 3 1 value here by diffuse, that's how you get the shadow effect. And then we have 3 more values here that we added. We have the float 3 reflection, which is reflect, and it takes the light direction and the normal. And then we get view direction, which equals normalize, and it's a normalized account of negative world position. That's also another thing to make sure that it's in the right position, like these -1 and -1 values. So we have negative world position minus ray origin. And then we have one more float, which is specular, a power, so like you have a value and an exponent. We'll talk about this in a second. The value that's being given an exponent is a maximum of a dot of reflection, comma, view direction, and 0. So in the video, this was just a 16, but at the end of the video, they show you something pretty interesting that I thought I'd give its own variable for. Basically, if you change the exponent value in that power, you can change how the light looks. The bigger it is, the smaller that point looks. You can change the style a little bit. You can make it look bigger by giving it a smaller number. You can even make it look kind of cartoony. There, that looks kind of cartoony. Actually, it does look a little bit weird when you have to look all the way around. Or you can give it a bigger number and basically like change it to look that way too. So yeah, in order to get the effect itself, we add the original return plus specular times float3 111. So basically just white. So the whole return is basically diffuse, which is a max dot with the normal light direction and 0. Multiply that by the original return, which would give us our sphere, but the backside of that sphere is now in shadow. And then to get the actual light, multiply this whole variable here with the exponent by white. So you get that little white, you get some shadow, and it looks like it's an actual object in space. And then you can change the light position with this variable. So yeah, you can make the angle look a little bit different depending on what you want to do with that. And then you can just like put it on a static mesh, and then you can try to calculate how you want it to look based on the position of where the sun is in your level. So yeah.